So this is the agenda we agreed on, or this is the agenda with a small change we agreed on Tuesday. We have swapped in one new document that is actually version 01, I think, into the discussion of the source identification, flow identification. The presentation will be made by Stuart, and he will also shortly talk about another draft. So is it okay to make that change to agenda? Okay, so I think we're good to go. Okay.
I'll be presenting first.
So it's easy. Tarek will be presenting first.
Yeah, I'm the button buddy.
Hi, everyone. Okay, I guess you can hear me well. My name is Tarek. I'm with Cisco Systems. I'll be the presentation today is about Yang data models for TE and RSVP tunnels and interfaces. We presented this work back in TE's session on Thursday, and this is just a brief rerun of what we presented over there. Thank you. So high-level outline of the presentation, the objective and scope of our work, progress update, some discussion points, and next steps. So back in Honolulu, we formed up a team that was interested in defining these Mpls TE Yang data model, and the objective were to coordinate the effort, define a modular structure for the model, and define submodules that would hold reusable derived data types that other modules in the future can import and reuse. Next, please. Thank you. So this is a high-level structure of the modules that we presented back in IETF 91. Basically, we had MPLS base at the top, and hanging underneath we had MPLS TE base, which would be augmented by the different signaling protocol, an example of which is RSVP-TE or SR Spring TE. And we had also MPLS static, LDP, and so on. This is what we started with, and on the next slide, I'll show you what we proceeded to develop. So because MPLS data plane is not the only data plane for traffic engineering, we thought we would have a data plane agnostic model, and then we would augment that base TE data model with MPLS data plane specific attributes. So what we ended up with having a base TE model and then a base TE RSVP model, and then you will see that MPLS RSVP TE is augmenting that. We did have to define a standalone RSVP Yang model just because RSVP is not necessarily only used for MPLS. So what's in scope of our work? Basically, the base traffic engineering Yang model, the base RSVP Yang model, a base MPLS packet RSVP TE Yang model, and extensions to the base model for other like segment routing traffic engineering and MPLS TP. This is what was in scope of our work. Next, please. Thanks. A progress update. We were holding recurring meetings since IETF 91. The team met once a week, and our work is kept in GitHub. We also have a wiki where we keep important decisions there. Next, please. Thank you. This is a high-level module structure and the relationship between the different modules we are proposing. You'll see we have reusable types defined for MPLS, and then we have reusable types that are data plane agnostic, the TE-based Yang model, and the different RSVP-TE, for example, is importing that and augmenting it. And I can show you an example on later slides how we're doing that. The RSVP model is being imported by RSVP-TE and being augmented by it, and so on. The important thing is at the bottom you will see that we are defining the TE MPLS RSVP, and we expect different data plane technologies will define their own modules and augment the respective module. Next, please. Thank you. So this is a high-level structure of our module of the TE-based Yang specifically module. You will see that we have a TE container that holds the tunnel interfaces and global configuration. We have also the tunnel state, LSP state, interface state, and global state. The actions are also defined, or at least a placeholder for them, and the notifications. Next. Thank you. More detailed for the TE-based data model, you will see under globals we have the admin groups, the named admin groups, and the named SRGs, the named explicit paths, the named constraints, which are basically groupings that are given a name and you can reuse them and apply them wherever you need to. And then you have under the interfaces, you will see there is a placeholder where you can reference a named admin group or a named SRG and the specific attributes of that interface. Next, please. Continuing on in the same module, we have tunnels and the respective attributes of it. And we have two branches for the tunnels, the point-to-point and the point-to-multipoint. Thanks. Next. Okay. We're good here. So this is the RSVP data model, the RSVP-based data model. It contains globals, again, interfaces, interface-specific attributes for RSVP, the sessions, the neighbor state, the sessions configuration, neighbors configuration, and state. The detailed attributes are in the draft. I encourage you to go through them and provide us with comments, which is always welcome. Next, please. So this is the RSVP-TE extensions to the RSVP base model. You will see more of the TE extensions that augment basic RSVP as defined in RFC 2205. So this is the RFC 3209 extensions to RSVP to signal LSPs. Basically, we are augmenting the RSVP module and the TE base module at the same time. Next, please. Thank you. So next steps, what we want to do is complete our outstanding work with respect to the state, the actions, the notifications for the TE-based module, and the RSVP-TE modules that we're proposing. What we wanted is to converge on what goes into the base MPLS module. We're thinking that common attributes across all MPLS control plane technologies could be held there. That's one proposal. The other proposal is we could hold the data plane state in the MPLS base module. So this is still an open question at the moment. And we want to continue on with, as I mentioned earlier, the MPLS statics, spring segment routing, traffic engineering, and TP. Next. That's about it. If any questions, feel free.
Hi, Lou Berger. You didn't mention that there's also the issue of needing to reconcile the base model with GMPLS pieces and then GMPLS technology-specific pieces. And you have to sort of work out the framework of how that's all going to hang together.
Yeah, right. I agree. There is a little bit of concern of how is it MPLS augmenting GMPLS or GMPLS augmenting MPLS? Is that what you're trying to say there?
I think there's well, first of all, it applies to broader than just RSVP. You know, it certainly applies to signaling. It also applies to the whole LSP management picture. But how we do technology agnostic parts, so things that are truly common across everything, right, and then technology specific parts. Right. A fallout of that is the question you just raised. But that is, to me, a one point in the whole topic.
So I think the impression we have had, Lou and I and a couple of others had, is that when it comes to any of these models that are truly generic, that would be done in a routing working group. It turns out that that is no longer true, so we need to sort this out among ourselves in the protocol owning working groups, and I guess we need to do that after this week when we have had all the information boiling up.
Yeah, and I had an author just recently ask me what to do about that exact type of problem. And I said, don't worry about which group it happens in. Get the technology right, get it documented, put it in the document that makes sense, and we'll figure out the working group as we go. But if the technology piece, the definitions are right, we can deal with that other part. Even if we get it wrong in terms of the management structure, we end up with an RFC with the right contents.
Okay. Lou, we're out of time, so thank you.
And next is Cameron.
Hello everyone, I'm Kamran Raza from Cisco Systems. I'm going to just give a quick update on LDP and MLDP YANG module effort, on which a big design team is working. It's a multi-vendor, multi-operator team right now, from Cisco, Juniper, Ericsson, Huawei, Ciena, Orange, Comcast, and recently also Alcatel has shown interest to join this design team. Next one. So a bit of background, right? So during IETF 91 in Honolulu, right, as per direction from Mpls working group, so there was an effort that kick-started trying to collaborate YANG model for MPLS, different areas of MPLS. Accordingly, as Tariq mentioned for TE, we also have the similar meetings going on for LDP during Honolulu, and initial design team was formed. After that, and this was multi-vendor team as I already mentioned, and then we had also invited other people to join and people who have interest in this work by sending email to Mpls working group and routing YANG coordination list. And after that, we also got a few people who joined our work after our invitation. So it's an open group. Everyone is welcome to join. And we, after that, we have a weekly meetings since last IETF to this IETF, almost 12 or 13 weekly meetings we had, where design team met. We agreed on overall structure of LDP and MLDP YANG model, and we were able to post draft right before this IETF, version 00 of the draft. Next slide, please. Right, so goal of the model is very simple, of course, to define LDP and MLDP YANG data model. We had discussed during last IETF whether MLDP and LDP should be separate document, but I think working group direction was that it should be in the same document, given MLDP is directly dependent on LDP. So right now our scope is to cover both LDP and MLDP. Scope is basically to cover base specification for LDP 5036 and MLDP 6388, cover any address families in LDP for V4 as well as V6. Also, incorporate LDP capabilities framework. Intent is not to cover each and every RFC which is out there for LDP and MLDP, but at least we wanted to cover all the most significant extension to LDP, which makes sense. So some of them are type wildcard, FAC extension, end of lib, upstream label assignment. So this module already incorporated all those specs. Few things to mention about the scope. So some of these things right now are not in the scope of this document and the work that we are doing. Specifically any LDP application, for example, ICCP, how do you signal ICCP using LDP or pseudo-wire signaling, they will be defined, they should be defined in their own respective YANG model for their service provisioning or application provisioning. Mpls OM is not addressed in this document at this point in time. It's beyond the scope of this document. as well as multi-topology LDP is not currently in the scope of this work. However, we may revisit this later on. Next slide, please. Right, we have few dependencies as everyone else, of us do right now. We don't have any Mpls based model right now, so we started with work through routing instance, and we are right now off routing instance. But we will have to probably realign once Mpls based model is out there. So our model has to realign. There is also dependency on WRF-centric versus proto-centric approach as we converge during this IETF, and decision as to go with WRF-centric. So we will have to do some work in our draft, minor work in our draft to basically align with the WRF-centric decision that routing working group has made. And a few other things like routing policies and whatnot. So these are our dependencies, but that doesn't stop us from doing things within LDP YANG model. Next one, please. So in revision 00 of the draft, what is addressed is basically right now LDP YANG model, no MLDP is there yet. In LDP we have covered configuration, notification and RPCs. We haven't addressed state yet, but that is our next revision is targeting. And in this 00 we are supporting instances in a proto-centric view. With minor work, the model is ready to go to WRF-centric. We are addressing both V4, V6 address families and all the cool features like label policies and whatnot. Next one, please. And what is not addressed in 00 specifically at this point in time is operational state for LDP, and anything else for MLDPs is also not covered. Next, please. All right, so starting with LDP configuration. So right now, as I mentioned earlier, it's proto-centric. We have defined under a default routing instance, but we will realign this draft to go WRF-centric with minor work. Currently, it is residing under routing instance and having its own routing protocol identity called LDP. Through this model, we can do some configuration hierarchy and inheritance. We have parameters that you can configure on different labels. You can have all WRF scope, per WRF scope, per WRF, per interface scope. So the model caters to all these inheritance requirements. And there are many optional features in this model, in this configuration. Next one, Tariq. Right, so that's basically core of the configuration, config hierarchy and config subtrees that we have come up with, the design team that met many times. What we have, again, is a proto-centric. So we have global parameters which basically apply to all VRFs, or which apply to which are WRF agnostic. For example, you enable non-stop routing. It's really a global LDP feature. It's not per WRF or per routing instance feature. So there are global parameters we have defined, and then there's per WRF parameters. And per WRF parameters, we have also defined different hierarchy. There are per WRF per address family parameters. There are per WRF so there are per WRF parameters which are that are basically across all address families. For example, LSR ID or router ID is nothing to do with address family, but it's per WRF. So there are parameters for non-address family. And then from control plane point of view, we said LDP really we have to define discovery and neighbor configuration. And so we have divided into discovery parameters and neighbor parameters. And within discovery, of course, there are two types of discovery, which is interface-based discovery and extended targeted discovery. So the model right now aligns with the 5036 defines LDP2. There are a few missing things from 5036, but we have tried to address most common deployments. For example, 5036 talks about LCATM label space, non-zero label space. Current model only is platform-wide label space or label space ID of 0. But this is revision 00. If you get a feedback and from working group and need to also need to extend this to support non-zero label space, that will be future work. For now, it's a default label space ID. And then within interfaces, we have different list, and for targeted, we have different list. Next one, please. Yeah, so this is basically capturing what I just mentioned in terms of real tree, which currently compiles. So we have features, we have discovery parameters, which are global, and then we have per instance or per WRF parameters. We have the capabilities container, we have address family containers for IPv4 and IPv6, and within address family, we have our own subcontainers. Next slide. And this is again the continuation of the previous slide. So then we have discovery parameters per VRF, and then discovery is divided into interfaces, you can see there, and the targeted address families. Next one, Tariq.
Cameron, you have quite a few slides in about
Yeah,
1 minute.
just, okay. Right, next one, please. All right, so notification has also been defined. Next one. You can look at the document. We have also defined RPC's most common one, looking for feedback if there's a need for defining more. Next one. Right, so next step. So we have to clean up a little bit to make it verb-centric, but we believe that model is ready to move to verb-centric with the minor changes. We got some comments on Sunday. We got this review to Young Doctor on the Sunday session. We got some comments from Lada. We'll incorporate this in the next revision. We also got some private comments from few of people in our IETF. So we will address those. We will add, going forward, we'll add MLDP configuration first, and then we move to LDP state and MLDP state and whatnot. And align with Mpls base and routing. We are seeking more comments and feedback from working group, and we literally, the last bullet, we are really looking for more engagement and feedback from operators. We have few of them already on the draft, but we are looking for more if there's interest. Thanks.
Wait a second. Greg, while we take the question, come up. You can go on one question.
Rob Shakir, BT. I just wanted to say thanks very much for the work, because there's a lot of, it's very complete in terms of the configuration that's in there. We were just looking through. We were just wanting to understand how open you would be to, especially with the sort of missing operational state parts, structuring the model such that other models which might use slightly different layouts, especially around state, so we can just import the material that you have. So that we obviously don't want to duplicate work, but there looks like some restructuring that might need to be doing just around some groupings that would let that be imported pretty easily if you could do.
Sure, we're open, and we should probably discuss more.
Yeah, I'll drop you a mail and we can discuss on the list as well.
I would like you to actually put that on the mailing list and make the proposal so we can see the differences if you're talking structure.
Yeah, absolutely. It's mainly around how we presented a draft in NetMod around how state should be represented and where it should be stored in the model, and it's mainly around that element. Okay. So I will do.
You have to go ahead. Thank you, Cameron.
Thank you.
So while we're switching slides, I have one concern about almost all of the Young model document. It's a good concern, I think, because there are so many interested in the work. We have so many co-authors. When we come to publishing an ROC, we have a limit of 5. I might put the 6 through, but not 7 or 8. So if you are more than that, you need to think about how you will handle that, and the normal way of handling it is actually putting it in a section of contributors and then have just a few names on the first page.
Thank you. So that presents a new work as most of our Yang efforts. Can we go to the next? So LSPPing is a widely used and very powerful diagnostic troubleshooting tool supported by many implementations. Can we go next? So this is Ref 0. It's based on 4379 RFC. MIP provided as a reference, defined control schedule parameters and result information. But not everything is in this version. Can we go next? So the pings extension and updates not in. Point to multipoint is not in, and shroud is not in. So the control information allows to configure true parameters and references the MEB, support reply mode defined only in 4379, not defined in several extensions, and parameters that control frequency and execution of their ping. Next, please. Schedule parameters, again, some schedule it executed to be right now in a certain time, and stop parameters that can be defined through existing proposed model. Next. Result information. LSP ping presents one of the cases that have been discussed in the netconf netmod as a long-running command. And doing the model of long-running commands is a challenge. I think that there are two options discussed. Is that polling using RESTconf, and another that we are in our document is that suggest to look at LMAP reference model, which includes controller, measurement agent, and data collector. In this case, the node that executes LSP ping can be viewed as their measurement agent executing measurement task. The measurement task defined by measurement method with the specific parameters. And according to LMAP framework, their LMAP group is working on defining the control protocol between controller and a measurement agent, and data protocol to export data from the measurement agent to collector. I think that it might be a very productive way of addressing long-running commands. And we'll appreciate your thoughts and comments on that. So we can go next. On the next step, continue the work. We welcome your comments and contributions. And as I said, we'll be addressing these gaps that have been identified, including that traceroute mode, extensions, and point-to-multipoint support.
Hi, Greg. I have a question. This is Tarek with Cisco Systems. Does your work cover segment routing and segment routing traffic engineering LSPs?
Okay, that's a very good question. Not yet, because as stated, their 0.0 version only concentrates on 4379, and even that not covered in entirety of the RFC. But I agree with you that it should include, as we'll be looking for all essential extensions to LSP ping. There are numerous, but
Greg, a comment on that. All the drafts that are addressing LSP ping for segment routing is still in working group or individual state, so you have a little bit of a problem modeling them. I'm just saying you should be careful. You should do it.
Yes, yeah, I agree. That's a very fair and warning and note that don't rush things before they settle.
Okay, so I think we have to stop there. Thank you, Greg. And next up is Ina.
Hi, my name is Ina Minei from Google. I'm here to talk about yet another Mpls Yang data model. And this is the outcome of work done by the OpenConfig operator working group. Since this is the third time I'm presenting these slides, and probably the 8th OpenConfig presentation at the IETF, you're all familiar with this group is. Basically, it's a group of operators interested in network programmability. And to that goal, next please, there are two very key things that run across all the models. One is that the models have to be vendor neutral. The other one is that they have to be usable, and they focus on use cases. So the idea is not to have exhaustive coverage, but to cover the functionality that is most useful to this group. Next. The Mpls model, back to the Mpls model. So the Mpls model that is proposed here covers both label switch path and the protocols that are used to signal them. The LSP configuration is driven by the LSP type rather than by the signaling protocol that is used to signal it. This is a similar approach to what was done with the TE and RSVP models, and it's very familiar to a lot of router configurations where many times protocol and LSPs are separate. The type of LSPs we cover are traffic engineering capable, non-traffic engineering capable, and static. which are very unfortunate names. If you can think of it as explicit path, IGP congruent and static, if you find it more intuitive. And the signaling protocols can be, RSVP, LP, segment routing. We're not precluding BPLU, we just haven't added it in the draft as is now. The model as it is now lays out a generic framework in which all these different types of flavors of LSPs can fit in. Next, please. So what does it look like visually? So we have at one level the LSP types and at another one the signaling protocols. Next. So why do we even want to have a model like this, and why structure it this way? So, well, we all know why we want to have a model. It's because we want to have intent-driven configuration and operation. And if that is the goal, then the focus that that brings is actually on the functionality rather than on the mechanics that you're using to achieve that. So on the tunnels rather than on the signaling protocol. So that's why the model kind of like is built around tunnels, which is what you end up touching most from an operator point of view. You seldom tweak your protocol configuration or your protocol timers, but you tweak a lot the tunnels themselves. Next. So this is the very high level structure, and I'm not going to go into any more details than that. We have three main sections. One is global section, specific to the MPLS forwarding plane. Another one is signaling protocol specific, and another one is LSP specific. And then underneath there, you will have separate sections for the different signaling protocols and for the different flavors of LSPs. The model as it is now is focusing on RSVPT tunnels. That's how it came together. This was the first use case that was interesting to this group. It doesn't have an LDP implementation yet. It has a skeleton of an LDP implementation. So why am I even here in this working group presenting? So the purpose of this presentation here is just to make people aware of this work that is happening and of the framework into which we want to structure the model. Skip next 3 slides. Yes, skip next 3 slides. No, next. So in terms of next steps, what we want to focus on is continue building out the model, in particular the LDP and the SR functions. And to this end, we want to leverage work that's being done by other groups. So we want to take a look and evaluate how we could leverage the work that's been already done, for example, for LDP, and fit it in the model, whether it is usable, whether different groupings would allow us to reuse it in a better way. We are going to have a new version of the model in the Young repository, and then we'll seek out feedback from vendors on implementation readiness. And I was expecting a lot of people to come and beat us up at the mic. Thank you.
Thank you, Ina. I don't think we really have time for questions and discussion here now. Please take this to the list, and I think it's important that we actually get that discussion going. There is a routing coordination, Young, I don't remember the name, I will send it out on the mailing list. But there is also a discussion going on that list. So next up is Lujan.
Yeah.
Hi, we're going to talk about the HSDN. We just issued the O2 draft. So One mistake I made, I just sent to Tarak now, but it's kind of late, is I missed the one co-author. As the third one after Vijay is Deepak Bandel from Microsoft, who's leading a development team for SDN networking and overlay SLB and so on. So that's something I missed. We'll change the upload after this. And we have co-authors from various system vendors, silicon vendors, and large cloud providers, service providers, and so on. And Remke is with Dell. I didn't have his
No,
name.
no, you do know you'll need to think hard
I
about
do.
who's really an author at some point.
I do know. Yeah, thank you, Ras. Next page. So for this one, the update is not major since 0.0. We basically gather a lot of feedback. There was a pretty active discussion, a lot of are offline, some are online, and we, based on the feedback, so we extended the clarification on the label semantic for both ECMP and TE. We always have the TE covered, but one of the feedback from Sharam was saying, hey, you didn't explain enough, so we pull a separate session to explain enough, but we always have it. And we add a reference to a companion draft with the BGP LU solution. Next. So here are some requirements when we started the work. The work actually the thinking been in Microsoft for quite some time, and our work really hard to nail down the solutions has been more than a year. Oh, sure, I was there. Yeah. So for
Luann, could you
be quick?
concentrate on the changes and not do the
Oh
whole-
yeah. Okay. So the changes are minimal. And what I want to bring up is there are a lot of questions on base concept. So we don't need to go through the background, but what we want to do is we have a very, very large scale cloud network. Today we have more than 1 million servers, and others have some may have similar situation. Eventually the scale is a concern. How to scale it at low cost. So we want to reduce the FIP size. We want to be able to traffic engineering. That's the way you can eventually avoid the loss of packet and be able to increase utilization. So that's the main goal of this draft. So we didn't start with saying, let's do MPLS for something, or let's use BGP for something. We said, how do we solve this problem? And then we concluded we need some sort of in-cap label to go. Which is that label? We can invent a new in-cap, or we can use MPLS stack. MPLS stack is there. All the vendors can support it. So that's the route we went. It wasn't start with the say go with MPLS for something. Next page. I want to just give a concept how the key point of this architecture is not on which protocol to use. It's how to decompose the problem to divide and conquer. We have a huge domain. If we keep it flat, it's very hard to achieve our goal. So we say we partition it. We have the different hierarchy, and in each hierarchy we have a partition. Partition in a way, this dimension is very low number, so we can use 3 or 2 label to go over. This dimension is also, each one is small, but in general you can just horizontally scale it. Then the same for control plane. Next page. These are the two we think is a fundamental property for the HSDN. One is we pre-established all the paths, the way we configure the FIP. And the other one is identify the entire path or group of paths. That depends. If you do ECMP, you just need to identify the border group. If you do TE, every path is identified. So all the paths are built. When you do it, when you run the real time, all you need is a smart scheduler to be able to put the flow on the right path. Okay, next one. So here's a little animation. And if you have a packet want to go from this server all the way to that server, we start from our endpoint as a server, and by the way, our overlay is all endpoint server. So the server is the underlay endpoint, and we'll label in position. Next page. Animation. Yeah. So we'll label in position. Forget about number 14. The inner label can be any overlay technology. Just the top 3. Number 4 is the top label. That entry is in every node pre-configured. And then it goes through all the way to the other data center. Number 4 indicate which data center you're going. And then go down. Go. Yeah. And then go down. Number 28. Tell me which the next cluster is. It can be a row, it can be multiple, depending on your architecture, the design. The design is very important, where the connectivity is right and where the sites can be cut right. And then the last one will tell you which server to go. So beyond that, it's overlay. We don't talk about it here. Next page. Here's our label semantic. Instead of using label in the regular way, we give label the meaning. So a partial will identify the path, the other part will identify the destination. That's in each domain. So you find your border node. Next page. Yeah, so same for the control plane. We partition. I think I'm running out of time. Let's go. Yeah, next. Oh yeah, control plane we also did BGP part. So between now to the end goal, some people say I don't want to have a protocol. Some people say we do have existing. I would say we have to migrate. So we will leverage any existing like a BGP functionality to be able to distribute label and so on. We started that work in IDR and we'll continue that. And this is just a number from our analysis to show if you have 3 million endpoints, the server endpoints, if you use this architecture, among all switches in the core in the data center, the largest flip side is 1K, about 1.3, something like that, if it's 4 million. So it's around that number. And if we want to do TE capable for any to any with this architecture, 14K. And we calculate to up to 40 million. You can say even if you want to do TE, LT, it's 32K. So it's a very, very small flip. That means lower the cost. Next page. We welcome all the feedback and discussion, and we'd like to ask for working group adoption as appropriate. Thank you.
So before we go to working group adoption, I'd like a clarification. You have it as standards track, but you're not asking us to do any protocol work or change anything, so it seems it should be informational.
Okay, we'll talk with you, George.
Yeah.
There's like certain things we had a thought. There's certain small portion touch the label and so on. Maybe we can move it out if it's need to be standard. If the information is information of the
Yeah, I
we'll
mean,
talk.
until there's something that needs to be,
Yes. Okay.
it has to be information. I want to make that decision before we do a work group call for adoption. Okay.
Okay.
Okay. Thanks.
Adrian Farrell, thanks for the presentation and for the work. I'm just wondering what the criteria is to be an author on this work. I have several friends who'd like to have their names added to the front page, if that's possible.
The criteria is this. We started this work, there are a few authors really did extensive writing and so on, and the others are saying, I have more like to add input. For example, our Facebook co-author, our Bell Canada co-author saying, I have input, want to work with you to add more into it, and our Shiram, and then we were working on that. There some contributed text so far, some are going to. Eventually we cannot have even everybody contribute text, we cannot keep that long list, so we're going to shrink it down.
Sorry, Shahram Devari Brother. Yes, so first of all, I mean, I'm not a co-author, so obviously I support it. The good thing about this draft, I think, is that it doesn't really require any change to our hardware. So that I wanted to make sure that that's what was actually happening, and we can support this, existing chips. We don't need to modify the chips. That's one aspect of it. Secondly, the reduction in the table size, that's a big deal because it costs us to add, memory to do these are hash table lookups, right? They're quite expensive. And the third thing is that I try to help with the draft for the traffic engineering part of it, so to make sure it's clear how it's done. Thank you.
We're going to have to move on.
Thank you.
But Luann and her co-authors actually had the hardware size in mind and the capabilities and table sizes, so it wasn't by accident.
Okay, so I'm going to talk about the flow identification work that we started a little while ago. Can I have the next slide, please? So this is the draft that we agreed to generate at the last meeting. As is common in the IETF, we did it at the last moment, but 01 represents the thoughts of all the authors. Next slide, please. So the key operational need that caused this draft to be written is a necessity to do passive packet measurements in customer network to determine customer packet loss. This is not easy in MPLS networks where label merging happens, such as in multipoint to multipoint or multipoint to point, ECMP and FRR cases, make it much harder than the MPLS TP case that we originally designed 6374 for. So the goal is to provide operators with the ability to conduct 6374 passive measurements in these cases. It turns out that there may be other interesting uses for flow identification, but it was this that drove it, and as we think we go through the work, we should identify other uses. Next slide, please. So the problem is that you've got only the destination label that you can, or the label that's got your local context in to work with. So we need to encode somehow or other additional information to measure flows, substructure in those flows, and also it turns out in most practical equipments to batch packets up, so that we can do the accounting at both ends without huge, very complex, difficult and expensive synchronization problems. So next slide, please. The other problem that we have to deal with is that path and queue length vary. So it's not just the end stations that need to synchronize the flow, the demarcation point with the packets coming in. We do need to make sure that by the time the packets have got through queues in other paths, that we can reconcile everything out with everything that came in. So next slide, please. So what do we need to identify? Well, clearly we might want to identify all the packets from a particular source. We might want to figure out groups of packets from a particular source. For example, all LSPs are on a tunnel. We might want to do per flow within an LSP, so fine-grained measurement of some characteristic of the traffic that's going across the LSP. Next slide, please. So we set some scope constraints here to make the problem more tractable. The set of flows that we're interested in have to be uniquely identifiable at the ingress LSR. So some people have asked me what I meant by no assistance from outside the MPLS domain and within the LSP domain. The point is that we don't want to tag additional metadata into other parts of the packet to make this work. We've got a bunch of MPLS labels, we have to do it with the bunch of MPLS labels, and we have to do it with the signaling that goes between a pair of of PEs. So this is an MPLS problem. We have to solve it in MPLS land. We can't say just move the labels across to the left a bit, stuff some metadata in, and we'll use that. Next slide, please. 100% requirement is it has to be backwards compatible. We can't change the MPLS architecture. We certainly can't change it for this. So we mustn't stop any existing feature working. We must be able to cope with incremental deployment, and it has to be a service that you explicitly enable and run, doesn't run unwanted. Next slide, please. In order to do that, we might relax some relax some constraints. So, for example, we might require a point-to-multipoint situation that all of the leaves have got the same capability and they all can have this feature turned on at the same time. So that's just we just want to make sure that we want to solve the 99% problem. We don't want to add huge amounts of complexity for the last percent. Next slide, please. Whatever we use to as identification of the flows and the components of the flows and the batches must minimize the changes to the MPLS data plane. Ideally, there should be no change if we can get away with that. Would be an ideal solution consistent with the long-term philosophy of MPLS. Whatever we do, changes need to be small, general purpose, and non-limiting. That is to say, we mustn't do anything that risks backing the MPLS architecture into a corner. The other thing is that we need to be respectful of the scarcity of reserved labels. In particular, I'm talking about I use the term reserved labels to mean the 0 to 6, 0 to 15s, and the special purpose labels to mean the new extended ones that have a reserved label followed by the 0 to 65K. So we have to be really super careful of those 0 to 16s, and we also need to try and respect the stack size, because there's a lot of equipment that can't cope with expanded stack size, and of course it's possible that we will want to instrument multiple nested components with this sort of thing. So I might want to instrument a packet going to another net, and that might itself want to do some sub-instrumentation. Or I might want to instrument the LSP and the pseudo wire. So we have to be very careful that we don't grow the stack ridiculously large. Next slide, please. Privacy, we need to think about putting all this identification in whether there is a problem. Next slide, please. So next steps. So the authors believe this is an important piece of work to be done. We think it should be done in the MPLS working group. And I think it's sort of time to think about moving it into MPLS working group control rather than just the textual control of the authors. So I think I would like to suggest that we consider this for working group adoption early, so that we can more readily take everyone's opinion into account.
Okay, we got that message.
Okay, thank you. Right. Has anyone got any questions on this before I go to the next very short one?
You have just a couple seconds over 2 minutes now. So.
Okay.
Sorry, Sharon, though. Is this kind of an extension to what Huawei presented many IETFs ago, that kind of a source label?
No. If you read the next draft, if you read the next draft, you'll see that there are other ways of implementing the feature.
Okay.
So I'll just spend a couple of moments on synonymous flow labels. We originally worked on this in the 6374 context, but I think actually synonymous labels have a wider context, and wider application, and we should think about that some more. Next slide, please. So what is a synonymous flow label? A synonymous flow label is designed to be a label that causes exactly the same forwarding behavior at the egress, at the receiver, at the egress LSR, exactly the same behavior as the label that it is synonymous with, except that the synonymous label causes a side effect. And the side effect may be, for example, to increment a packet counter, hence the discussion in this context. It may be to send the packet over for monitoring. It may be to give any hint that you want. The important thing is that we use the MPLS protocols to set the main label up, and we agree with the peer that there will be another label that has exactly the same properties as the first, but with some additional properties. And this gives us quite a powerful tool for use in things other than just simple batch marking of packets.
So I just want to make clear that the synonymous label is used instead of the main label, not with the main label.
Indeed. Sorry, I should have made that clear. It's a replacement label, as in a synonym.
Sorry, Sharon. Then why do you need two labels? I mean, basically, you're adding a context to the main label.
No. So, for example, let's say I want to do simple 6374. I set the LSP up, for example, right? And then I decide I want to turn on 6374. So I say, hey, could you give us two labels that you will forward exactly the same as this original, but instead what I want you to do is to count this label against this counter.
During that
this
period of time you're doing measurement, you want to use
exactly
this one. Okay,
during the measurement, or for any other feature that we want. But the important thing is the main protocols negotiate their labels, and then underneath that system we create a synonym that has the additional special property we want.
The idea is to be able to count things without you changing your hardware.
John Messenger, you've called it synonymous because it's not synonymous, right? I mean, I would advise you to think of a name that has a meaning rather. This is a misnamed label.
We can talk about what we actually call it. So the nice thing about this in particular, in the performance measurement case, I've only got one more slide.
So you need to wrap it up real quick.
Okay, is that most of the hardware can do this. Next slide, please, then. So you see the label stack looks exactly the same size as it did before, but we just have the replacement label in it. Next slide. So what I'd like to request people do is to read the draft, give us feedback. We're really interested in it. There are two other drafts. One is a control plane draft. That was written to show what the properties of a control plane might be. I'm not precious about it. There was another draft that showed, interestingly enough, that you could run some of these performance measurements without even having the GAL in, which may be an advantage in certain circumstances. So please read it. We would like to hear feedback, and hopefully we can talk about it at greater length next time round. Thank you.
Thank you.
Okay. Ron Bonica, and we're going to talk about LSP self-paying. You saw the draft for the first time in November in Honolulu. Since then, we've revved it a few times, added an author. Oh, we're still waiting for the slides to come up. We've revved it a few times, added an author, asked for a call for adoption. We had the MPLS review team review, got many comments back from it. These are the resolutions to those comments. What we would like to do is inform the group of what the resolutions are, rev the draft, and ask for a call for adoption after the draft has been revved. Next slide. Next slide. Okay, here are the comments, and they're grouped under some general categories. One of them is applicability. The first comment is LSP self-ping doesn't detect some kinds of errors. For instance, a misprogrammed LSP, where the LSP pops out at some place other than the intended destination. And the response to that is to add an applicability section to the draft. LSP self-ping isn't the generic OAM mechanism. It's not meant to detect every error that you could possibly detect. It's applicable in exactly one scenario. An application like RSVP has just signaled an LSP. It's received notification that the LSP is either installed or will be installed very, very soon. And you need to disambiguate that message. The application doesn't need to confirm the correctness of the programming because it's very likely correct. And in this environment, control plane resources are very, very scarce. The reason why is, in this case, RSVP is signaling not just one LSP. It might be signaling tens of thousands at once. So it's all about being lightweight, and it's all about just detecting this one type of error. Is forwarding state installed all the way downstream? So, in this scenario, LSP ping and FBFD are not viable options. Next slide. Next comment is LSP ping doesn't work for LDP independent mode. In the applicability section, we say, yes, we understand that. We're only applicable in this one situation where we've just signaled with LSP. Next slide, with RSVP. Next slide. Okay, the next comment was LSP self-ping doesn't work when reverse RPF checking is enabled on core-facing interfaces. Here again in the applicability section we say, yes, we understand that it doesn't work when reverse RPF checking is enabled on core-facing interfaces, but fortunately it doesn't matter because generally when you're using RSVP you don't enable reverse RPF checking on core-facing interfaces. If you did, any traffic coming in through an unexpected interface would get dropped, and in that case, what's the sense of using RSVP in the first place? Next slide. Okay, the next is they asked for a comparison between LSP ping and SBFD. We took a look at SBFD. Well, first we'll take a look at the functional comparison. The only real difference between them is SBFD. In SBFD, the ingress sends a packet to the egress. The egress swaps the source and destination ports, swaps the source and destination addresses, and sends a response. In LSP ping, the ingress sends a packet to itself. All the egress has to do is forward the packet as it would forward any others. Next slide. So, what are the benefits of SBFD? It would detect LSP programming errors, it would work for all types of LSPs, and it would work when reverse RPF checking is enabled on the core. Those are the three things that a minute ago we said, yes, we don't take care of, but they're out of scope for the application we're looking for. The cost of SBFD, first, it must be supported on the egress. Second, it must be supported in hardware on the egress. If not, the packet has to go to the control plane, and just because you're sending so many SBFD probes in the control plane, you might actually be slowing down the process that you're monitoring. In this case, being lightweight is what it's all about. So LSP ping, self-ping, for this application is the right tool. Maybe not for every application, but for this application it's the right tool. Next slide. Okay. The next is bidirectional LSPs. Use of two self-ping sessions to validate bidirectional LSPs may be acceptable in the case of associated bidirectional LSPs. In case of co-routed bidirectional LSPs, which are usually egress signaled, such approach doesn't seem practical. And here we will add some explanatory text to the bidirectional section of the draft, where the active side calculates the ERO, signals the LSP, and runs self-ping. Passive side reverses the ERO, signals the LSP, and runs self-ping. Neither side routes traffic over the LSP until the local self-ping returns true. Next slide. Okay, the next was a big one on conformance. Carlos pointed out that we use the LSP self-ping packet format, but we violate the rules that were in LSP self-ping. The way we fix that is by breaking the dependency between LSP self-ping and LSP ping. We define a new packet format. So now the only thing that LSP ping and LSP self-ping have in common is a very similar name. They don't share a packet format anymore. Also,
they still share the same UDP port, though, right?
No, they don't.
They don't?
No, not even that. So the only thing they have in common is the word ping in their name. You'll see that in another slide. Actually, that's the next thing that we're going to talk about. We're going to emphasize the distinction between LSP self-ping and LSP ping. Completely different protocols. They listen on different UDP ports. They behave differently. The only thing they have in common is their names sound similar. And actually, I wouldn't be averse to changing the name. Next slide. Okay. Security. We taught in the security section, we say that LSP self-ping packets can easily be forged. And there was a suggestion, why don't you add something to the security considerations text saying you should discard packets with unrecognized sender's handles, make the sender's handle unpredictable, and also filter LSP self-ping traffic at the network edge. All good suggestions. They'll go in the security consideration section. Next slide. Okay, the next comment was that using a dynamic UDP port makes it difficult to filter at the edge. That's probably true, so rather than using dynamic, we'll ask for a static port for IANA, and different from LSP pings. Next slide. Oh, the next is the draft classification. We were sitting on the fence before about whether it should be PS, BCP, or informational. Now that we're defining a new packet format and we're asking for an allocation from IANA, I think we've stepped over the line and it has to be PS. So that's our best guess, but if anybody thinks otherwise, speak now. Next slide. So, oh, and the last comment was use RFC 1219 language, and since we're going to PS, of course we will. Next slide. Okay, next slide is to update the draft with all the changes that we have on here. I wish I could have done it earlier, but we just agreed to those changes Monday. And we will go ahead with the call for adoption if the chairs are amenable to that. That's it.
So I had one concern about using somebody else's address in a packet, you know, mainly the destinations of packet. And I have this technical question that I haven't been able to find the answer to yet. Is it illegal to send out a packet that has the same source and destination address?
I don't believe it is, and I think GRE Keep-Alives do that today.
So why don't you do that? Because I think the security people might not like that.
George, I think that BFD base, BFD echo does exactly that, puts its own IP address as a destination address for their in 5880.
So do GRE Keep-Alives. They've done it for 20 years.
So why don't you do that?
Oh, I do. I address the packet to myself.
No, I mean, but the source address, you were using the destination's address, right, in the packet?
Actually, I think that's configurable. By default, it's the destination, but it's configurable. I can make it anything I like.
Why don't you make it default to the source?
Okay, I can make it default to the source.
Robin Harwick.
Robin, we cut the line after Robin.
Only Robin. Okay, I have one doubt to be clarified. It mentioned here not support the LDP independent mode. So I have one question is that for the sales pin that is we have the use case is the proxy egress SP. So this support the proxy egress or not?
Proxy egress LSP.
Yeah.
I'm not sure what the answer is. For every application other than this one, I guess you would have to sit down and think about it. You're sending a packet through an LSP addressed to yourself. If there's a proxy egress, how would it behave? How far would the packet go across the LSP before it came back to you? And that would determine how much it tests.
Okay.
You know, right now I'm saying it's applicable in only one scenario. It might be applicable in others, but it's up to the person who wants to use it there to figure out if it's applicable.
Okay.
Okay, thanks, Ron.
Okay, update the draft and, okay.
So we have...
I'm ready to the airport.
Hi again, this is Tariq again, and what I'm talking about next will not be about Yang, it will be about RSVPTE summary fast reroute extensions. Next slide, please. Thank you. So the outline of my presentation today, requirements and scope. I'll talk about the summary of the proposal and the next steps. So fast reroute, as defined in RFC 4090, is heavily deployed in packet MPLS networks. We all know that. In scale deployments, the point of local repair and the merge points, they can host tens of thousands of LSPs at one time. In the event of a failure, the PLR and merge point control planes become overwhelmed with the work that they need to do in the control plane to complete FRR processing. This is usually done on per LSP. The primary motivation of our work is to allow the FRR procedures in the control plane to happen on per groups as opposed on per LSP. And ultimately, we want to scale our RSVPT LSP deployment. So the scope again is LSPs as defined in RFC 3209 and FRR procedures as defined in RFC 4090. Next, please. Next. So the summary of the proposal. Next, please, Loa. Next. So this is the description of what happens prior to a failure. The PLR will create and manage these groupings, and it will exchange them with the merge point in advance of a failure. The way that this is transmitted is via the RZP record route object, and for that matter, we're proposing to extend a new sub-object called summary FRR bypass assignment, and it'll be exchanged in the path and RESV RRO object. What it contains is a summary FRR group identifier, which associates the LSP with a group, basically. So the merge point learns about this group identifier and acknowledges it by reflecting it back in the reservation record route object. Once the PLR receives this reservation RRO that contains the summary FRR bypass, the handshake is complete, and we consider the LSP to be summary FRR capable. Next, please. So post a failure, what happens is the PLR notifies the merge point with the list of affected summary FRR group identifiers by sending a new object in the path message. We were defining this new object, and we call it summary FRR bypass active object. What it contains the group identifiers of all affected LSPs, basically. So it sends one path message that contains this list of group identifiers. The merge point processes invokes the normal FRR handling. When it receives this, it identifies the LSP associated with the group, and does nothing but what RFC 4090 proposes. In order to acknowledge that the FRR processing happened on the merge point correctly, the merge point responds back with a reservation that contains the bypass active object. Again, nothing but an acknowledgement that everything worked fine. I can take the question now, if you like. Go ahead.
Yeah, Chandra from Juniper. Quick question. So when would the merge point create the backup LSP state? Was it like before failure when you do the handshake, or after failure when the PLR sends the bypass active signal?
So the bypass tunnel is created in advance as usual, as per RFC 4090. The backup state happens after the failure, and it happens in a summarized fashion as it happens today. I have a slide that describes exactly that, existing versus the proposal. So it's actually the next slide. Yeah, so this is just a diagram that shows what happens now versus what happens with our proposal. After a failure, there will be a backup state, a state created over the bypass tunnel by sending a path and reservation. So if you have N1 associated over with bypass 1 states, you'll have to send N1 path messages, respond with N1 ResV messages. Similarly, if you have other states associated or protected by another bypass, you'll have to do that with so many multiplied. With our proposal, you'll have to send one path message and one ResV message for all affected LSPs. So the signaling is scaled down considerably during this window of recovery from FRR in the control plane.
Chandra from Juniper. So if I understood you correctly, it's like when MP receives the bypass active object on the bypass LSP, so it actually now auto creates the backup LSP states as if it has been refreshed by the PLR. Is that a correct characterization?
Yes. So what we're proposing in the draft, it invokes the RFC 4090 merge point procedures as is on the affected LSPs as identified in the group. So we send a group, and all the LSPs will be handled the same.
So which means the backup states also, okay.
Yes.
Looking from Huawei, one thing I want to be clarified, that when you send the summary, that's the LSP, the identifier, this information will include or not? Is it just only a summary?
So inside the LSP state, prior to the failure, and as part of the record route object, we will insert this group identifier. It's not the LSP identifier, it's a summary FRR group identifier. Now the LSP ID is inside the sender template, and the session objects are already there. What we're saying is in the record route object, you will have this new sub-object. It's called summary FRR bypass assignment sub-object. It contains a group identifier.
Okay, so that means no specific LSP's information, only just a...
No, the LSP information is already in the signaling as usual in the session object and sender template.
Okay, I have another possible way, because I remember that when the failure happens,
So Robin, we are very close to time for Tarek, and he needs to wrap up. Take this to the list. The discussion is interesting.
Okay. I just that idea is maybe use hello for summary.
It's actually creating the backup state as Chandra was pointing, and we have to do that as per RFC 4090. What we're proposing is a summarized fashion of how to do it. We're not eliminating it. Okay, thank you. Next slide, please. So next steps, which is the last slide, we welcome comments from the working group. So welcome any comment, please send it on the list. And ultimately, we want to request working group adoption for this document. And finally, I want to mention that we have a prototype code for this, and it pays off. We've noticed that our scale shows good results with it.
Now, you have an update to do before you would want to request adoption, is that right?
Yeah, we might have some update, and yeah.
Do you have time for a comment from Java?
10 seconds.
So Lou, on that one, Lou wanted to know why not use bundles?
So we still have to process every message, and identify the LSP and process the this per state processing in this case. The proposal we're doing is to do in advance as much as possible by grouping the LSPs and identifying them with a ID. So we think that this is more superior than sending the bundles, which you have to do in multiple bundles versus one message in our case.
Chandra, are you ready? Thank you.
I am Chandra from Juniper. So, in the last...
By the way, I thought I just might mention quickly for people in the room, we're likely to run 5 or 10 minutes over our original scheduled time.
I would try to keep it short. So, okay. So, we are already presented this in the last IETF at Y. The next slide, please. So we have added a couple of few authors there. So the goal of the there was a draft yesterday on TRs, which is BRM Mpls scaling. So where the primary goal is to make RSVP as much refresh independent as possible, and this RFC 2961 got us probably because it says that you can actually make the refresh time actually as large as possible, but that is actually the one way to make RSVP refresh independent. So what we are actually trying to do is, there are some parts in RFC 4090 that actually has some dependencies. That is, when we say it has dependencies, it actually a node has to make some guess, has to have some timers while dealing with large number of states. And when that happens, when there is a guess, obviously something that works on some scale wouldn't work at a higher scale. So that's the goal, and we had some updates to the draft from last time. Next slide, please. This is again, I wouldn't go through this. This is like it gives an example where where actually the nodes actually make a guess. For example, in this case, it's a node protected LSP. P is say the failure happens from B to C. C now has to make a guess when it should actually send a path tier to D. When the refresh interval is small, okay, we can let's see C could actually time out the LSP. But if we say make the refresh interval long, as the other draft proposed, which is at 20 minutes, C has to now have some make some form of guess, which is like there is a refresh dependent component in RFC 4090, which we actually want to remove. And next slide, please. So there are 3 extensions that are proposed. So the 2 extensions that are described here, which is the MP determination and conditional path tier, there is no change to the draft from last time. MP determination is a mechanism by which a node knows whether it is a merge point or not. And we actually use the existing RRO flags, which is the local protection available and node protection flag. These flags are defined already, and we actually use it for RESV. Why not use it for path message and actually signal that a node actually knows that it is a merge point? And if you look at this example, we said like C has to make a guess of when it has to delete a state and send a path tier. Now let's say if you want to remove that guess, let's say C is let's say not a merge point. For example, it is not a merge point. It now sends a path tier. D, rather than sending a normal path, vanilla path tier, if it sends a conditional path tier, D can, if it knows it is a merge, node protecting merge point, it can retain the state. If it is not a node protecting merge point, if it's not a link protecting merge point, then it can delete its state. So the conditional path tier is actually a new object that has been defined. We have not changed that from the last version of the draft. So next slide. So this is one part where we actually did some change. So a remote path tier is a path tier that is like a normal path tier, except that the hop object in the path tier message contains the node ID address of the PLR. Because we now propose to run a node ID hello session between PLR and merge point. So the merge point now will know what the node ID of the PLR. So if the hop object contains the node ID of the PLR, so PLR MP would know that the PLR has actually sent a path here. So it has actually deleted. It can actually now free up the state. So this particular use case, particular application of remote path tier is one that is update from the previous version. That is for a back-to-back failures that happens. The example where two links of C go down back. I mean one after the other, and while the C really still remains up. So it's like there is no node failure there, but there is like two link failures. So in those kinds of cases, what happens is B would now do the normal FRR, signal the backup, get the RSV back from D, which means the RRO of the LSP would now have changed. So A, when it gets the RSV, will find that C is no longer in the path of the LSP. So A can send just a remote path here directly to C to clean up the state. This is again because C would have learned it is a merge point. It doesn't again have to guess when I have to delete the state. It is explicitly turned down by the PLR. So it's like the goal is to remove any kind of a timers or any kind of not require any node to make any guess and when I have to delete the state. So next slide. This is okay. I will skip this. Next slide. So I have a question whether if there are any comment. I mean, we would welcome any comments if there are, and I will also put up a question whether this is fit enough for working group adoption.
Are there any comments? I also have a question. Has anybody not signed the blue sheets? A few in the middle. Okay, I'll take one back in the middle while our last speaker comes up.
This is Minji from Juniper. I'm here to present the first version of our proposal solution to a common set of problems. Next, please. A current practice of the make before break for RCPT LSP is that the procedure normally involves the ingress router initiate a new instance or new tunnels and signal the LSP, and a new set of labels will be allocated. This involves LFIP need to be reprogrammed for the new label assigned, and also the ingress application using the LSP has to be notified to switch over to the new instance. Obviously, there are some disadvantages of this practice. Any LFIP update takes time. This adds delay to the LSP setup. As previous presenter have indicated, there's a need to do verification of the data paths when the new LSP comes up. Also, the dependency of application to the LSP, which means that there's significant overhead in terms of updating the applications with the new LSP. Next, please. Here's a diagram of the flow of the new LSP setup. So when the paths go from router 1 to the egress of router 6, the reserve comes back and assign labels. As you can see that we have a small segment in the middle between R3 and R4, even though that there's a large overlap of the path of the old instance and the new instance. And regardless of how much overlap it is, a new set of labels for the new instance or new LSP are assigned along the path. In this diagram, it shows that there's no label reuse whatsoever. Next. So we're proposing a change in this behavior that the LSRs can reuse label if there's a segment which overlaps completely with the old instance of the LSP all the way to the egress. Of course, the benefit is contrasting to the disadvantages we showed before, that whenever the label is reused, there's no update in ingress, the transit or egress. When we have complete overlap of the path, that means none of the update is needed, and the state transition between the old instance of the LSP to the new one has no impact on the LFIB or route. Next, please. So the algorithm is pretty simple, that the label assignment start from the egress of the router. It will always reuse the label and advertise upstream. When transit router advertise the label from downstream, it will check two things. One is that is receive the label the same as before, and is the next hop exactly the same. If both conditions are met, itself can decide I can reuse the label assigned upstream again. So there's a progress all the way to the ingress and stops at any router which decide he has not met the condition and cannot reuse the label. The ingress will also do the same check, and if the condition is met the same as the transit router algorithm, then it can decide that nothing needs to be updated, even when it's switching from the old instance to a new instance. Next. So here's a diagram showing the difference. Notice the label reuse is marked as blue lines, and the only segment can be reused the label is the portion from the egress to R4. And in the best scenario, if between R4 and R3 are the same path, which means you have a total overlap, which means the label can reuse all the way for the whole path of the LSP. Next, please. This algorithm tries to focus on one specific condition, which is the primary path of the P2 MPLSP, and other types of conditions is tracked by different studies. We'll be proposing in the future. I'm open to any questions.
We are well over time, so I don't think we can take the discussion here. Try to initiate the discussion on the mailing list. No. Okay. So, thank you everyone. We conclude the MPLS working group meeting here in Dallas. See you all in Prague. Pavan, are you here?